So this is a question from image problem, just 2022. In this, they have asked, what is the charge stored? What is the energy stored in this configuration? How much energy is stored in this configuration? So this is a conducting plane, okay? I mean a conductor, infinite sheet you can consider. And the infinite sheet is at zero potential. So they have asked that how much charge, how much energy is stored within this configuration. So you know that this is a problem. This is a problem that belongs to image problem. Okay, we do such problems using image problem concept, in which we changed this problem into another problem, and because of uniqueness theorem and because of the boundary conditions, it will exactly give the result like original problem. Okay, so I will replace it by uh, another problem in which plus q is here and minus q is here, and this is exactly at distance d. And now uh, this was a conducting plane here, but in this case just consider this as imaginary surface, just a surface. Okay, and if you calculate potential at this surface, you will find that the potential is exactly 0, because it will be 1 upon 4 pi epsilon naught. Uh, so calculate the potential at this point. Take this point as P. So 1 upon 4 pi epsilon naught q by this distance, 1 upon 4 pi epsilon naught minus q by this distance, and that potential will come out to be 0 at each and every point. So now both conditions are satisfied here, that in our region of interest, we want to calculate the energy of this system. So in the region of the interest, the charge is still plus q. So that's why Poisson equation is followed, and the boundary condition that this surface should be at zero potential is also followed. So because of uniqueness theorem, we will get exact result of this configuration in this change configuration. So now forget about this configuration. Okay, so this configuration will give you, if I consider this as z cap, so this will give you a force is equal to 1 upon 4 pi epsilon naught, and q1 q2 will be q square by the distance 2d uh, whole square. Okay, so if I consider this distance to be d, it will be 4d whole square, and this will be attracted downward. So I will put a minus z cap vector. So this is the force, and this force will be felt in the original configuration. So because of this plus q charge, you know, the conducting plane will acquire a negative charge, and that will be attracted, that will attract this charge. So that will attract by a force which was difficult to calculate in this original configuration, but that force is this much. So because of the uniqueness theorem, you can say that this is the force that will be experienced by this charge. Okay, fine. And now the question was asked that what is the energy stored. So we can make a mistake here, that energy is 1 upon 4 pi epsilon naught q1 q2 by r. So that will be equal to 1 upon 4 pi epsilon naught q minus q, that is minus q square, by r, that is 2d. But this is wrong. Okay, why this is wrong? Because for calculation of energy, we will be going towards this charge also, and that will violate our uniqueness theorem. So that's why this will give you a wrong result. So what we have to do is actually, when you see the original configuration, when you bring this charge, you have to do work to bring this charge. Okay, the energy will involvement will be there to bring this charge, but the charge moving on, the charge on the surface, which is induced charge minus q, they will be also, they will also start roaming around. But since they are at zero potential, no energy involvement will come in this picture. So that's why when we calculate energy using this charge also, you will get a wrong sense of energy. This can be a common mistake that you can do. So actually, the energy is just half of it because of the single charge involvement. So I can tell you the answer, that will be equal to minus 1 by uh, in place of 4, just put 8 pi epsilon naught and q square by 2d. Okay, so it will be just half of this energy, and we can calculate this by putting the uh, integral from infinity to this point d and writing the force. What is force? It is q square by 4 pi epsilon naught, and let me put the force at some distance z, so it will be 2z square. This is the force, and we are moving in the direction of force, so dot product will give you dz. All right, because both are in the same direction. Force is also attractive force, it is in this direction, and we are bringing it from infinity to this point. So see this configuration, we are bringing it from infinity to this point, so we will have dot product angle is equal to 0, cos 0 is equal to 1. So if you calculate this, you will get q square over 4 pi epsilon naught, and this will be 1 by 4 factor here, 1 by 4, and 1 upon z square will be minus 1 by z infinity to d. Okay, so you put upper limit minus lower limit, so it will give you q square by 4 pi epsilon naught, and it will be minus 1 by d, so it will be into minus 1 by 4 into 1 by d. I have taken negative sign. Okay, so compare these two. This is also 8 into 2 16, this is also 4 into 4 16, so both are the same result. Okay, so this is very interesting question, and it actually this question is about uniqueness theorem. Are you clear in your mind about uniqueness theorem and Poisson equation? In Poisson equation, del square phi is depending on rho. Right hand side you have rho and epsilon naught with negative sign. So are you clear in your mind that that charge density should not change in the region? So if this q is there, this q should be there. That is okay. So that's why you got the right calculation for force. But as you started discussing about energy, because you have to see this charge also, so that's why this was giving the wrong impression, and that's why we have calculated by the basic formula and you got the right answer. Okay, so I will suggest you to read this in Griffith. He has written beautifully with complete information, so I suggest you to read image problem and this problem also from the Griffith. Okay, thank you.